Okay, in this video we're going to continue our work with solving for particular variables in formulas and extend that idea to working with what we call literal equations. And an equation that has two or more variables is called a literal equation. And to rewrite this literal equation, we want to solve for one variable in terms of the other variable or variables. So in this particular example, we have 3y plus 4x is equal to 9. And our goal is to isolate the y. So we want to protect the y. We're not going to touch it. We're going to get rid of everything else around it though. And we're going to first subtract the 4x. Remembering that we get rid of addition and subtraction before we get rid of multiplication and division. So we would subtract 4x on each side. And when we do that, we want to remember that 9 minus 4x cannot be combined because they're not like terms. And so we can't simplify that any further than to say that that is 9 minus 4x. And so we're left with 3y on the right, 3y on the left side. Then from this point, we're going to divide both sides by 3, and we would end up with y is equal to 9 minus 4x divided by 3. Now, that's fine as a final answer. Some students may want to go further and to separate this into two different terms on the right side. So we could do y is equal to 9 over 3 minus 4x over 3 if we wanted to do that, and that would also be equal to 3 minus 4 over 3x. So that is also all right to write it in that form there, and actually that's going to be helpful with things that we're going to do later. So either of those are fine, and you could stop at the first part or the second. We'll go on to the next example. So in the next example we have y is equal to 3x plus 5xz, and we still want to isolate the x, or to solve for x. The problem here is that we have two x's. And right away some students might think, well, let's combine the 3x and the 5xz. But actually the 3x and the 5xz are not like terms, so they can't be combined together. So we're going to have to use another strategy for this type of problem. And that strategy is called factoring. And you can think of factoring as the reverse of the distributive property. So factoring is the reverse of the distributive property. So I'm going to start with the n, and then let's see if we can convince ourselves that this is fine. If I had x times 3 plus 5z, like so, when you see that, you might want to think to distribute. And when you do that, you're going to end up with 3x times x times 5z is 5zx. But it's the same as 5xz. Remember, multiplication is commutative. We can change the order of the factors without changing the product, the result. So since that works, I'm going to go over to the left side, and I'm going to actually, what we say is factor out that x on the left side and rewrite as x times the quantity 3 plus 5z. And if you want to convince yourself, you can go back and distribute just as we did over on the right side there. Now, why is this helpful? Well, you can see now that we only have one x We haven't really gotten rid of it. We've factored it out, and there is this implied multiplication that's going on between the x and the 3 and the x and the 5z, but we don't see it there. All right, at this point, we have made the x a factor of the numerator, and so we can simply divide both sides by 3 plus 5z. Now when we do that, we can rewrite with the x on this side. Of course, the 3 plus 5z's cancel on the right side, and we end up with x is equal to y over 3 plus 5z. Now, I do need to point out that unlike the previous example, and I'll call that up for a second, which was y equals 9 minus 4x over 3. Unlike this example that actually can be split up into 9 over 3 minus 4x over 3. This example here cannot be split up, and I want you to pay attention to what makes it different and why it cannot be split up. So here we'd have, x. Here we have x is equal to y over 3 plus 5z. Now notice that in the denominator of this second example you have 3 plus 5z. That cannot be split up, unlike the 3 in the example before. So when you see multiple things in the denominator, multiple terms connected by addition or subtraction, remember that you cannot split those up. You cannot split those up. It doesn't equal y over 3 plus y over 5z. It does not equal that. All right, so with this example, this is as far as we can go in terms of simplifying what we have here. All right, we're going to stop this at this point and continue some more examples in the next video.